Hello everyone, I'm going to discuss a sample problem in the topic thermodynamics and heat transfer. This is in heat transfer chapter 11, combined conduction and convection heat transfer. A 4 meter by 4 meter flat plate maintained at a constant temperature of 80 degrees Celsius is subjected to parallel flow of air at 1 atmospheric, 20 degrees Celsius, and 10 meters per second. The total drag force acting on the upper surface of the plate is measured to be 2.4 Newton. Using momentum heat transfer analogy, determine the average convection heat transfer coefficient and the rate of heat transfer between the upper surface of the plate and the air. We have here the given numbers. We have the friction force. This is equal to 2.4 Newton. And we have two temperature here. We have the T sub S is equal to 80 degrees Celsius and T sub infinity, we have 20 degrees Celsius. And the V is equal 10 meters per second. This is the velocity. And the properties of air at 20 degrees Celsius and 1 atmospheric are found in the table A-15. So we got here the Prandtl number 0.7309. The specific heat 1007 joule per kilogram degrees Celsius, and the density we have 1.204 kilogram per meter squared. Because both sides of the plate is exposed to airflow and thus the total surface area, this is equal to 32 meters squared. So to get we get the total surface area. So for flat plates, the drag force is equivalent to friction force. The average friction coefficient CF can be determined from this equation. We have the friction force is equal to friction coefficient times to the total surface area times to the density times the velocity squared over 2. So we're gonna get the average friction coefficient. So we'll have this equation. Substitute all the given to the equation and multiplying it to this equation to cancel all the units. Calculating that, we're gonna have this final answer for the friction coefficient. Average friction coefficient, we have 0.006229. Then the average heat transfer coefficient can be determined from the modified Reynolds analogy to be this equation. So we have H is equal to the friction coefficient over 2 times to the density times velocity and the specific heat over the Prandtl number raised to 2/3. So substitute the given numbers, calculate it all using your calculator, and we're gonna have this answer 46.54 watts per meter squared degrees Celsius. Because we're getting the rate of heat transfer between the upper surface of the plate and the air. So we have this equation. Let's substitute the numbers to this equation and we're gonna have the final answer. We have 89,356 watts. So this is in watts. So that's all.